Hey, this is Niels on Dynasty. Please like, share, and subscribe. Be kind, helpful, and grateful, because it's better than being a jerk. Buy yourself some crystallized osmium and some silver, some platinum, and some crystallized osmium. It's not financial advice, it's just advice. Crystallized osmium H. But anyhow, that's not what this is about. This is about look up in the sky. If you walk outside one night and you think it's morning time, look up. Corona Borealis 69 or something like that just exploded. It happens every 80 years. And we're going to get to see it in our lifetime. So unless you're probably 90 plus years old, you've never seen it before. So basically, it's a once in a lifetime event. Should be happening any day now. Astrologically, that means within the next 6 months.
Looking up at the night sky, T Corona Borealis might soon burst into life, outshining its neighboring stars for a few nights. Known as the Blaze Star, this star is located in the constellation Corona Borealis and has the potential to become visible again after nearly 80 years. In this video, we will explore the science behind this extraordinary event, why it holds significant importance, and what it can reveal about the universe and the life cycles of stars. T Corona Borealis, or TCRB, is not just a single star, but a binary star system composed of a white dwarf and a red giant. These two stars are locked in a cosmic dance, with the white dwarf gradually stripping hydrogen from its red giant companion. When enough hydrogen accumulates on the white dwarf's surface, a thermonuclear explosion, which is known as a nova, occurs, causing a dramatic increase in brightness visible from Earth. This phenomenon is akin to a gigantic hydrogen bomb detonating on the star's surface, unleashing energy tens of thousands of times more powerful than the sun's annual output. The fascinating part of TKRB's story is its recurrent nature. Unlike supernovae, which occur once and destroy their progenitor star, novae like TKRBs can happen repeatedly. The system has recorded flare-ups in 1866 and 1946, and some historical records suggest earlier occurrences in 1217 and 1787. The periodic outbursts are driven by the cycle of hydrogen accumulation and ignition on the white dwarf, making TKRB a recurrent nova with a flare-up roughly every 80 years. Current observations have shown that the star began to dim in 2023, a behavior similar to the pre-eruption phase noted before its 1946 outburst, leading astronomers to believe it might erupt again soon, possibly by the end of 2024 or early 2025. This won't be just a stunning celestial show, but also a rich source of scientific data. Each eruption provides a unique opportunity to study the physics of thermonuclear explosions on white dwarfs, allowing astronomers to refine their models of stellar evolution and binary star interactions. These kinds of observations.
Okay, another thing that's happening here is saying this white dwarf is sucking hydrogen, but there's a lot of other things being sucked in as well into this white dwarf, not from its sister star. But when it goes supernova or flashes like that, it also shoots out because of the intense heat and pressure. It's like making a diamond, but out in space, and it's not diamond, but lots of minerals get shot off in all directions when this happens as well.
Using X-rays and radio waves enable scientists to piece together a more comprehensive picture of the underlying processes.
Say goodbye to old costly cable TV.
But why is observing T Corona Borealis so important? For starters, TCRB provides a window into understanding a class of stellar explosions that can occur in other star systems throughout the universe. By studying these explosions, we gain critical insights into how stars evolve, interact, and sometimes end in violent eruptions. Moreover, novae like this one serve as natural laboratories for studying the
Yes.
conditions that lead to more catastrophic events, like Type 1a supernovae. This type occurs when a white dwarf accretes enough mass from its companion to reach a critical threshold, resulting in a catastrophic explosion that can outshine an entire galaxy. This is crucial to astronomers because they serve as standard candles for measuring cosmic distances, aiding our understanding of the universe's expansion. While TCRB is not expected to become a supernova anytime soon, studying its behavior helps scientists better understand the conditions that might lead a recurrent nova to evolve into a Type 1a supernova. The potential upcoming eruption of TCRB is also significant for fostering public interest in astronomy.
All right, enough on that. One thing they don't say that needs to be said is thanks to the James Webb Telescope, they're coming up with a theory that we are inside, our galaxy is inside a void in the galaxy, and if that's true, there's enormous amounts of space, extra space between our galaxy and our universe and the next universe in the total galaxy that they didn't anticipate, and that's changing. That's why they showed you the candles and why this is so important for them to be able to accurately judge how far things are away, because the James Webb Telescope is seeing past the Kuiper Belt and all this stuff, and the math behind if our universe is in the center of a big blotch of nothing, and then the rest of the galaxy is all together, and then there's other blotches of nothing. If we're inside one of those blotches of nothing, it changes all of the calculations made up until that point. And that's why they're now trying to say, hey, well, the Big Bang might be 26 billion light years away, because we didn't account for the 71 billion light years of open nothingness in between our galaxy, our universe, and the rest of the galaxies and the starts of those universes. So that's also a new discovery that hasn't been talked about. That changes a lot of stuff. And as the papers come out, we'll be informed. You guys have a nice evening and look up. Bye.